On 5-6 day 2, like I mentioned already, these are not going to be lines necessarily today. These are going to be nonlinear ones, but we're still going to find the inverses. So those steps that I gave you yesterday, as far as take the f of x out, replace it with the y, switch, solve for x or solve for y, same process. Just now we have a little bit more, maybe a little more work to do than before. So for this particular thing, what's the first step? Okay, switch it to y. Then what? Do the old switch play. Okay? And then how do I get y by itself? And when you square root it, what do you get? I get y equals, what on the left side? Thank you, Bryce. Plus or minus the square root of x. Okay? Now, here's one thing, though, that I have to do, back up a little bit on that. On the original problem, x squared is a parabola. However, it had a restriction on it. So here's what happened if you were asked to graph it. That particular original one, if you graph the parabola, and remember we've graphed parabolas before, something like that. Should have touched the origin, but that's close, right? But when it says x is greater than 0, is it graphing all of the parabola? Where would x be greater than 0 at? Right here and over. So would the left side of the parabola even exist? No. So when it has a restriction on there like that, it's like, hey, I'm starting here, I'm starting over, and then I'm going to start there, and I'm moving forward from that. Okay? So it's like a half a parabola. So then there comes to this part. When I find an inverse of that bottom piece like that, if you did plus or minus, you'd have a sideways parabola. But what part are we only referring to? Are we referring to the bottom half? If the top half said x is greater than 0? No. So we'd only have this part and not the blue piece. Okay? That blue piece would not be there. So when you have restrictions in there, which not a whole lot of them do, you'd only have one part of it necessarily instead of two pieces. Negative would be down here. Negative's that way. Okay, now from here, the next part that they're going to say is they're going to have f of x equals 2x to the third plus 1. And it says, determine whether the inverse of f is a function. Then find it. So how you determine whether an inverse is a function or not is you do one simple test. I know you guys have graphing calculators, and I know you guys know how to use them. What I want someone to do is I want someone to plug that equation into your graph and tell me what it looks like. I want 2x to the third plus 1 graphed. What does it look like? Turn. I know I went probably a little bit too wide on that part, but is that close enough? Okay, now, in order to determine whether or not a function has an inverse, is you do one simple test on the graph itself. What you do is you perform what they call the horizontal line test. The horizontal line test tells you if it's going to have an inverse. If any horizontal line hits the graph more than once, it does not have an inverse. Okay? So, horizontal lines, left to right, does that hit the graph more than once anywhere? It doesn't, right? So this will have an inverse. Okay? If it didn't, if it hit more than once, like let's say we took the whole parabola for the last part, not just the restricted part, but the entire parabola, would that have an inverse? No. Because of the fact that I would then hit it more than once. Okay? So the first thing they're going to have you doing is determine whether it has an inverse. Does this have an inverse then? Yeah, because it only hit the horizontal line only hits it once, no matter where you draw it. So now find it. Y equals 2x to the third plus 1. So I switched the f of x with the y. Now what? X equals 2y to the third plus 1. Subtract 1. Divide by 2. And then cube root it. So I have the cube root of x minus 1 divided by 2 over, or equals f to the negative 1x. What do you think?
Easy.
It's not too bad, right? Is it the same steps I did yesterday with the lines?
Mm-hmm.
Yeah. The only thing that you're going to have to deal with now is probably exponents. But as far as the adding and subtracting, multiplying, dividing, that's all the same. You just might have the exponents involved now. Okay? Let's see. Let's give you this one. Determine whether the inverse of f is a function. Is the inverse a function? Okay? If I sketch the graph for that, which just means plug it into my calculator and see what it looks like, will it pass the horizontal line test? Doesn't it do something like this? Horizontal lines are this way. Is it ever going to hit more than once? It's not. So therefore it does pass the horizontal line test, which means the inverse is a function. Where is there going to be a horizontal line that hits it more than once? No. One at a time. Does this horizontal line hit this particular graph more than one time?
No.
No. Does this hit more than one time?
No.
I'm just showing you different, multiple representations of a horizontal line. If it's like a U, then the inverse is not a function. You can still find the inverse, it's just not a function. Okay? So if it's a parabola, right, that inverse would not be a function. You can still find it, do the old switcheroo and solve, but it's not a function. Okay? So, as far as finding the inverse, now what? How do you know how to draw what line? You can draw it anywhere you want. As long as, Taylor, if that horizontal line, any horizontal line hits it more than one time, then the inverse is not a function. Then the inverse would not have been a function, right? So if it would have did something like this, if it would have gone, like that one that Tamara drew in her calculator was like that, Sarah? If it would have did this, where it would have made those curves, remember those ones we had in chapter 2, where we had to find the minimum and maximum and the increasing and decreasing? Horizontal line hits it more than once. The inverse is not a function. You can still find the inverse, it's just not a function.
So like with this, if I drew
No, it still is. Yeah, because looks almost like it, but that's why you use the calculator to help you. Okay? Because the calculator is more accurate than you are.
Oh, I was like,
Me too. Right. Okay, now what? I switch them. Now how do I solve? Divide by 2. So I have x divided by 2 equals the square root of y minus 3. Square both sides. So I end up with, now here's the part that most people will mess up. When you square that x over 2, it's not just x squared, because it's x over 2 times x over 2, so it'll be x squared over 4 equals y minus 3. Okay? You have to square the top and the bottom separately. Now what? Good. So x squared over 4 plus 3 is the inverse. Now again, the first part of it says determine whether it is if the inverse is a function or not. That's the horizontal line test. If it hits it more than once, the inverse will not be a function. You can still find the inverse if it's not a function. It just won't be a function. Okay? Then the second half of it is find the inverse. Here's the other thing that I'm looking at with the directions. I don't see anywhere where it says graph them. Okay? So, well, I guess the first part does. But most of the one, determine whether the inverse is a function, then find the inverse. Do you want me to do any more? Because that's pretty much it. Okay? So it starts on page 282. It goes 23 to 45 odd and 53.
it's 53